The example for doing your descriptives, your correlation, scatterplot, and finally the bivariate regression. And so I'm going to use, so that I don't use the same data as for your homework, I'm going to use the issue of tobacco taxes and smoking rates across the United States. And so I have an SPSS data set that is very simple. It's 51 observations. And here's the state cigarette tax. And here are the percent of adults who smoke. And you'll notice that the percent of adults who smoke is in a proportion and not a percentage. And I'd like it to be in the percentage form. So the first thing I'm going to do is a transformation called compute variable. So if you click on transform, compute variable, and then you can call this, I'm going to just call it smoke percent like that. And then I did that rather quickly for you. But if you have, what I did was I clicked percent of adults who smoke. That moved it into my numeric expression. The time sign is down here on your keypad. It goes plus, minus, times, and then divide. And then I'll multiply it by 100. And that should create a new variable. And we see that that's executed. And now I'm producing as well an output file. So I want to be sure to save the output file. So I go to File, Save As, and I'm going to call this 7508 tax and smoke, and it will be saved as an SPV file. And I'd like to save it to my desktop, which is fine. And so that gets that started. Okay, so now I'm going to bring that down a second. The next thing I want then are just my descriptive statistics. So I go to Analyze, Descriptive, whoops, sorry, a little bit fast there, Descriptive and Descriptives. And I had already been working on this, so I want to get rid of that. But what I'm going to do is do the cigarette tax and then the smoke percentage. And just I'm going to ignore the percent of adults who smoke is actually a proportion of adults who smoke. But let's just see what that looks like. And it gives us a table of that the minimum is 17 cents per pack, and the maximum is $4.35 per pack. And then the smoke percentage ranges from a low of 10%, which is probably in Utah, to a maximum of 27%. And in fact, I am going to just take a second to look at my data. So there's one of the like Arizona has a $2 tax and 17% of people smoke. I happen to know that the lowest state is Missouri, which has 17% and 21% of people smoke. The highest state tax is in New York, which is $4.35 a pack, and 14% of people smoke. That 10% comes perhaps, not surprisingly, from the state of Utah, which has a large Mormon population which doesn't smoke. And so they charge $1.70 a pack and only have 10% of smokers. So that's the first step. The second step then would be to actually do, you could either do your correlation coefficient or you could do a graph. I'm going to go ahead and do a graph. And so if you go to Graphs and you go to Chart Builder, okay, I think we're okay. And I go to Scatterplot. Then I can decide which of these I want. Wait, I don't like how this is working. So I'm going to just step out of this for a minute and cancel it. Go back to graphs here a second. Or if there was another place I believe you could do this, which I think was in data? So let's take a moment. Let's go to Analyze and go ahead and go and do the correlation coefficient, which is bivariate, correlate, bivariate. And I'm going to do it for the smoking percent. If you wanted to do it for all three, you could. It's a Pearsons, it's two-tailed, and here it is. So the Pearsons correlation says it's negative 0.566. Again, so that's a relative measure. It shows there's a systematic relationship between cigarette taxes and smoking. As taxes go up, smoking goes down. 0.566 is relatively robust. SPSS gives you the significance level, which would mean that in less than 1 in 1,000 samples, we would expect by chance alone to see this relationship at the bivariate correlative relationship. And so that's, it's interesting, I guess. And so we will continue. I'm going to take a second look at here. This is the better way to do it. To do the graph and the scatter plot is if you go to legacy dialogues, you'll see that there's a scatter dot option down here at the bottom. And for some reason, this is much more sane. And then you can do a simple scatter and define it. And you can define the y-axis. We're saying that the response is the smoking percent, so that becomes the y-axis. Whoops. And then the state cigarette tax is the causal, so that becomes the x-axis. We can add titles. So in the title 1, we'll say percent adults who smoke. And in title 2, we will call it, or in line 2, we will call it, in line 2 of the title, it will be cigarette taxes, tobacco. Okay. Let's go ahead and say okay to that. And here's our graph. The smoker percent and the state cigarette excise tax dollars. We could have made this title a little bit more explanatory. Again, I'm not terribly worried about it. And you can see the generally downward trajectory, that the higher the taxes are, the lower. This is New York way out here. This is West Virginia and Kentucky and other sort of heavily in Mississippi, some of the other heavy smoking states. So that's pretty straightforward there. So this leaves us now with just our regression. So we go to Analyze, and if you go to Regression, and then if you go to Linear, and then the dependent variable will be the smoker percent, and the state cigarette taxes is the independent variable. I'm going to go ahead and do statistics just to make sure I'm getting what I want, which it has the coefficient estimate. You can actually, in SPSS, since I asked, you can calculate a confidence interval by hand, but you can also have one. And then you can have an R squared, which is nice. Don't worry about the residuals as yet. That's the next course, really. And so there's that. So then I want the R squared. The model fit, by the way, refers to the standard error of estimate. And so I can continue with that. And is there anything else I want to do? I think I'll run this regression. Okay, and here's my regression, which says that the by the way, there is this goofy thing about enter in SPSS, and that dates from way, way back in SPSS when there was something called stepwise regression, which it is no longer. But here's my model, and the first thing I want to look at is coefficients. And I see that the intercept, so that if there were no tobacco tax at all, we would predict that 21.58% of estate adults would be smokers. For every dollar in cigarette taxes, the rate of smoking goes down by 1.93%, so almost 2%. So if a state had a $1 per pack tax, I would say it's 21.58 minus 1.93. If it had a $2 per pack, I would say it was 21.58 minus 3.86, which is 2 times the 1.93. The second thing I'm interested in this box, or mini box, is the standard error. which the standard error is 0.402. And remember, anytime that the standard error is less than half of the absolute value of the regression, it's likely a significant relationship. Or put another way, anytime that 1.96 times the standard error is less than the absolute value of the coefficient, then it's likely that. We see over here the t-value, which is simply the quotient of the beta divided by its standard error, is negative 4.805. And then what they call the significance value is, in this case, less than 1 in 10,000. So clearly it's a systematic relationship. Here's my confidence interval, by the way, which is from negative 2.74 to negative 1.12. What's important in that is that the upper bound is not above 0 or at 0. So that means that we can reject the null hypothesis that beta is 0. We are confident that it is a negative relationship, and that in 19 out of 20 samples of this size, we would have a value between negative 2.7 and negative 1.1. There is another feature that I forgot to put in here, so I'll do it in a second one, which is if you go to Analyze and then Regression, we can actually do the predicted values I asked you for as well, which is now, if we go to, yeah, let's do that. Options. That was not what I was thinking it was. Hold on. Predicted. Yes, I'm sorry, I did that too quickly. If you go to Save, what will happen is that, it will let you do predicted values, and you can go ahead and say that you want the unstandardized predicted values, since we're doing a linear regression, and go to Continue, and then now go to OK. And here we have the predicted values, okay? And it has the predicted value at it should have it at the mean and the minimum and the maximum. So the minimum for the minimum predicted Y value is what this is giving you, based on the highest cigarette tax would be 13.17. The maximum predicted value based on the lowest cigarette tax would be 21.25. And so that lets you sort of work through that. I think we need a little more practice with that in class, but it does let you do it, and you can compare it to your own values as well. In terms of what I wanted to look for in the model summary is up here, and that is what was our standard error of estimate and what was our R-squared. Our standard error of estimate is 2.89, which means that on average we'll be off by just about 3%, 2.89% as in the dependent variable. The R-squared is 0.32. It's not great, it's not terrible. Again, what's more important is that the standard error of estimate and that the standard error of the beta are systematic and significant. And the standard error of estimate this is down here in the residual statistics. They call it the standard predicted value, which is 2.76. So that's that's our basic output. I hope that this has been helpful. It would let you report the constant is 21.58. The slope is negative 1.93. Its standard error of the slope is 0.402. The t-value for that is negative 4.8 or just 4.8. And the confidence intervals between negative 2.74 and negative 1.12, and that's fairly important. By the way, the reason it's a t and not a z has to do with going to the general model and how much data we use up in making our calculations. That's not the technical, like how that actually happens, I wouldn't be concerned about. At this point, what I'll do is save this file. And so I can post it and you can compare. Yes, I want to replace it. Great. I'm going to go ahead and close that. And here, actually, by the way, in the data are the predicted values that have come back. So you can see them. I'm actually going to go ahead and cut them so you can make your own if you like, and I think that will be helpful. So whoops, it's not being cooperative. Go to edit, and let's just cut that. There we go. Okay, and so I will save this file out as well, and that should do it. Oh, this thing drives me crazy with the with that. Okay, and like I